Caves deep in the earth have always held a fascination for man. They were man's earliest home and a record of his day and age. The beauty of stalactites and stalagmites give pleasure to many and offer an adventurous frontier for caverneering clubs. An artificially constructed cave to house hydroelectric equipment can create as much interest as its natural counterpart. Poatina in northern Tasmania is an Aboriginal word meaning cavern. Set against a backdrop of the Great Western Tiers, Poatina is part of a vast power complex whose network traversed the length and breadth of Australia's island state. Completed in 1965, the Poatina Power Project is marked by radical engineering practice. 3,380 feet above sea level on Tasmania's central plateau lies the Great Lake, the largest body of fresh water in Australia, with a surface area of 60 square miles. The project called for a tunnel 4 miles long from the lake through the Great Western Tiers, carrying the water by a single penstock pipe down the mountainside to a powerhouse 500 feet below the surface. The water flows through a distributor to each of 5 generating units. At each distribution point, the flow is directed onto the buckets of a Pelton wheel connected by a common shaft to the generator. Generated power is taken by bus bars through an elevator shaft to a surface switchyard. For the initial tunnelling, a coffer dam was constructed in the Great Lake. In conjunction with the tunnel, an easement was cleared down the mountain in preparation for the penstock. The excavation of an underground cavern 85 feet high, 45 feet wide and 300 feet long was a major engineering feat. To enable the rock to support itself, a method known as rock bolting was used. Instead of a costly reinforced lining, a system of sprayed cement mortar known as gunniting was adopted. Access to the machine room is via a tunnel on a grade of 1 in 8 and an elevator. The Poatina project was not a wholly Australian venture. In Italy, a company specializing in high-pressure pipes manufactured the bulk of the penstock sections. To withstand great water pressure, the pipe sections were fabricated with a low alloy shell with forged high tensile alloy bands, hot shrunk on the outside. Water power design engineers, Irving and Company, contracted to have the Pelton runners cast in Switzerland and then machined in England with other regulating equipment for the turbines. The gigantic inlet and outlet valves were cast in Australian foundries. At the Tasmanian end, the Hydroelectric Commission made the turbine casings at its works near Hobart. As they became available, the penstock pipes were shipped from Italy to Devonport on Tasmania's northwest coast and taken overland to the site. Once there, they were stored in a pipe yard until given an anti-corrosive coating of hot bituminous enamel spun on the inside. The prepared pipes were swung onto a gantry straddling 2 rails and lowered into a prepared cradle on the mountainside. Great accuracy was required in welding, as each pipe was placed in its position. To excavate a tail race tunnel, which is situated below the machine room floor, the Robbins tunnel boring machine, more commonly known as the mole, was used. Built in the United States, this machine was completely redesigned by the Hydroelectric Commission for the Poatina project. Hydraulic cylinders provide the forward thrust on the tunneling machine, while steering jacks for vertical and lateral alignment keep it on course. As it tunnels, the mole passes the spoil back by conveyor to rail dump trucks. On this project, the mole established new world records for the rate of tunneling advance of any size in any type of material. In its best 6-day week, it bored 751 feet and covered a mile in just under 11 weeks. One of the mole's major advantages is that it eliminates the use of explosives and gives a smooth, circular shape to the wall. The mole demonstrated its tunneling accuracy when it broke through the final barrier to the machine room on the exact spot previously marked out in chalk on the wall. With the tail race, elevator shaft and penstock completed, the machine room was ready for the installation of the Pelton runners and rotor mechanisms. Each 6-ton runner taxed the skill of the low loader drivers who had to back their vehicles half a mile down the access portal. As each rotor arrived, it was lifted by 2 cranes coupled together on a lifting beam and lowered through the generator casings. Then the rotor assemblies were lowered through the casings and bolted to each Pelton runner shaft. Finally, the ancillary equipment was positioned, final touches were made to wiring and circuits, the control room benches were placed, and final adjustments were made to exciter mechanisms. On Tuesday, March the 30th, 1965, His Royal Highness the Duke of Gloucester arrived at Poatina to declare the project officially open. More than 400 people, representing a cross-section of the community, were present in the machine room for the opening ceremony.
Mr. Premier, Mr. Knight, ladies and gentlemen, I consider it my good fortune to be here today to perform the pleasant duty of starting the working life of the latest and largest of Tasmania's many hydroelectric stations, which I now declare officially open.
The sound economic structure of the state is due to harnessing natural resources. Poatina, the cabin, is a cornerstone in building the future.